Students, we have already learnt about what is a potential energy, what is a dipole. We'll now try to explore the same kind of thing with the help of an equipotential surface. So an equipotential surface also helps us in understanding more about finding out the potential energy because of other types of surfaces. This basically gives another insight to finding out the values. Like we had the Gauss law for finding out the electric field. In a similar way, we can use the equipotential surface to find out the potential energy of different kinds of surfaces. So now let's move on and try to understand about the potential energy due to an external electric field. So what exactly does that stand for? So when we talk about the potential energy in an external electric field due to a single charge, when you have just a single charge, you're just going to multiply that particular single charge with the potential. So that gives you the amount of potential energy of a particular charge in an electric field. So if you have a group of charges, what you are going to do in that case, generally we say that if you are given a combination of two charges, you are going to find out the potential energy of these and a combination of these. So this results from the potential at those points. So VR1 and VR2 are the potentials at those points, and this is the net result of those two charges. So when we try to find out from these two charges, so this gives us the net amount of potential energy. So let's try to understand this thing with the help of a numerical as well. So what we have, a charge of 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge of this from a point this to a point Q via a point this. So if we just try to put it in the form of a figure, so what we have, I know my drawing is horribly bad, but let's try to understand this. So if I say this is y-axis, this is let's say x-axis, and this is let's say z-axis. Why have I done this? Because there are 3 points. So here initially I have a point P which has the coordinates 0, 0, 3, and then we have to move to a point R which has 2 coordinates, Z, which has a coordinate along y-axis and z-axis. So this is my point R. From this point R I need to move on to the point Q. So this is my point Q that I have. So what will I have? So effectively I need to find out the distance between R and P first. So distance between R and P, so RP is going to be how much? It's going to be, if I just take the difference, so 0 square plus 6 square from 9 minus 3, so you're again going to be getting 6 square. This is going to be coming out to be 6 to 2. In a similar manner, what will we get? RQ is going to be how much? The value of RQ is going to be equals to, if I take the difference, 0 square plus 2 square plus 9 square. 9 square is 81, 81 plus 4 is 85, so it's going to be square root 85. Further, the distance OP is going to be 3, distance OQ is going to be 4, the distance OR is going to be equals to 6 square plus 39 square, so 36 plus 81 it is, so 36 plus 81 comes out to be square root of 117, which is nothing but 3 root 13. So these are the, roughly speaking, the distances that we have. Now what we are going to do, we are needing to find out the work done in taking this particular charge. Therefore, how to find out the work done? So the net value of work that we are going to do, so this value is going to come out to be equals to 9 into 10 raised to the power 9 into how much is the charge that we have? We have 8 millicoulomb charge. So if we talk about the 8 millicoulomb charge, so that comes out to be 8 into 10 raised to the power minus 3. And then what we have further, the other charge is minus 2 into 10 raised to the power minus 9. So if we put that in as well, minus 2 into 10 raised to the power minus 9, if I put that in here, and then I have to just find out, because this is the work done. So work done you are just going to find out with respect to the distances. So how much is the distance covered initially minus how much is the distance covered finally. So if I just take the distances, this is going to be coming out to be 0.04 minus 0.03. You don't have to worry about just any of the distances. So this is the initial distance, this is the final distance. You have to just take the difference of those two, and that should give you the answer. So the answer should come out to be 1.27 joules. Hopefully you understood till this point. Let's move on further. So what does a potential energy of a dipole in an electric field stand for? We have already understood that you have a dipole means it has two charges, one minus q, other plus q. Assuming that the distance between these two charges is nothing but 2a, so what you will have, let's say this is the center, so this particular distance is going to be a, again this particular distance is going to be a. So if you take a component, you will get a cos theta along horizontal, similarly a cos theta along the other horizontal, minus a cos theta. So the net potential energy, when you are required to find out, the net potential energy is nothing but P dot E, and you are going to find out the component. So if we just find out, so it's going to become P cos theta, you will take the P cos theta along the electric field. P cos theta, you can already find out Q into 2A. So that's going to give you the net value of the potential energy. Hope you understood till this point. Stay tuned for more. Hopefully you would have enjoyed listening to whatever we have discussed in the module. Now, if you still feel that there are any particular doubts that you have, so please visit our site www.askIITians.com. In this, go to the discussion board. Here you can find all the topics relevant to your questions. You can post your doubts in these relevant topics. And how exactly you are going to do it? Go to the right hand side corner of your screen. As you can see, you can select the category. The categories are defined here. You can select your category, type down your question. You can use your mathematical symbols as well. Else, if you have the question in the form of an image, you can attach the image, post it. We can assure you that the questions would be moderated and answered between 24 to 48 hours after you post it. So keep posting and happy posting. Thank you. So as we learned about how to find out the potential energy in the help of an equipotential surface. So this gives us a different kind of view to finding out the electrostatic potential energy values. We will continue further and try to understand about the different types of conductors as to what exactly is the electrostatics of the conductors. So when you have a conductor, how do the charges propagate from one point to the other, and so on and so forth, and what are the things that result as a well. So let's try to understand about this in our next topic.